So let's look at the 2010. Again, you can use a graphing calculator. They're talking about snow on Janet's driveway from midnight to 9 a.m. This is the accumulation function, f of t, where t is the hour since midnight. Janet starts to remove the snow at t equals 6. The rate in which she removes it is g of t, and it's a little piecewise function. So part A says how many cubic feet of snow have accumulated at the driveway by 6 a.m. So this is an accumulation, so it's an integral. So you're going to go 0, 6, f of t, use math 9, and you're going to get 142.275 cubic feet. Now, find the rate of change of the volume of snow on the driveway at 8 a.m. So the volume, you want to know how it's changed. So this is the rate of change right here. This is the rate that it accumulates. So we're going to look at f of 8, and that'll be 48.417. And then g of 8 is going to fall right in here. So that'll be 108. And f of 8 minus g of 8 is negative 59.583 cubic feet per hour. Now part C says let h of t represent total amount of snow that Jane has removed from the driveway t hours after midnight. Express h as a piecewise function with domains 0 to 9. Alright, so think about this. H of t is going to be h of 0 plus 0 to t of this function right here, because it's talking about the total amount that you removed. So if we're going from 0 to 6, we start out 0 to 0 is 0, and excuse me, this should be 0 to 6 because that's our thing. So 0 to 6, if you look up here, will be 0. So when we write our piecewise function, we're going to write 0 for 0 to 6. Now, how do we find out the next section, 6 to 7? We say h of 6, which we got from here, plus 6 to 7. And if we go 6 to 7, it's 125. But think about if you were taking the integral and doing it manually, you would do 125t, that would be the power rule, and you would say t 125t, you plug t in there, minus 125 of 6. So you can write that as 125t minus 6. That just gives you a way to represent them all. So you write 125t minus 6 for that section. Now, h of 7, we said it was 125t minus 6. So 7 minus 6 is 1, so it's 125. And then we go 7 to t. Well, what does it say it is? 108. If we do our power rule of integration, we get 125 plus 108t, and we'd be going from t to 7 here. So we would write it 108 t minus 7. So again, you would write it here. So it's just a way of using your manual integral rules to set up a function to represent all of the times. And part D says how many cubic feet of snow are on the driveway at 9 a.m. So we're going to go from 0 to 9, f of t, because f of t is the amount that came in, and minus h of 9, the total snow removed at 9. And so this will be math 9, we can do that. And here we'll use the function we just did. So we'll do 125 plus 108, 9 minus 7. And so you'll get 26,335. Now think why you did that, because it's how many cubic feet of snow are on the driveway at 9 a.m. So this was the amount that was accumulated, and h of t represented the total amount of snow that had been removed. So it's accumulated minus what had been removed. So let's look at the 2009 one. It says the rate at which the people enter an auditorium for the rock concert is r of t. and it's measured in people per hour. The door closes and concerts begins at time equal 2. No one's in the auditorium at time t equals 0. So how many people are in the auditorium when the concert begins? So door closes and concerts begins at t equal 2. So you want to know how many people came in from 0 to 2. So that's an accumulation, so it's going to be an integration. And you're just going to do math 9, and you're going to get 980 people. Now, part B says, find the time when the rate at which people enter the auditorium is a maximum. Justify your answer. Okay, so remember, you want to get your derivative to find the maximum. So if you do that, you can do your power rule. So if you do 2 times 1380, you get 276t minus, and if you do 3 times negative 675, you get minus 2t squared. So then you put in your calculator and find the intersection, because this is a derivative. And if you do, you get t equals 0 and t equal 1.36296. Now you want to check your endpoints also. So you want to check r of 0, r of this, and r of 2. And so you just plug those in the r function. And the maximum is going to be at this time period. So part C says the total wait time for all the people in the auditorium is found by adding the time each person waits and the derivative of that function. So function W is the total wait time, and the derivative is this, 2 minus t, r of t. Find W2 minus W1, the total wait time for those who enter the auditorium after time equal 1. So if WT is 2 minus t of r of t, and you go from 1 to 2, because it said t equal 1, then when you take the integral of the derivative, it's just the original function, which would be W2 minus W1. That's the first fundamental theorem of calculus. So that would be W2 minus W1. And you can use math 9, 1 to 2 of this function. So you would type 2 minus x, and then you would type the RT function, and you're going to get 387.5 people. So that's what it represents, and that's the amount. And says, on average, how long does a person wait in the auditorium for the concert to begin? Consider all people who enter the auditorium after the doors open, and use the model for total wait time. So you're talking about the W model. So average is the wait time divided by the number of people. So part C formula, but the only difference is we're using from 0 to 2 because that's when the doors open, divided by the total number of people. Well, you found the total number of people in part A, and part C you're using from 0 to 2. So it's 1 over 980, that's the total number of people, 0 to 2 of this. And you put it in math 9, and you get 0.776 hours. So the 2009 is talking about the storm washing away from the beach, causing the edge of the water to get closer to the road. So the rate at which the distance between the road and the edge of the water is changing is f of t. So that's your rate of change. And the edge of the water was 35 meters before the storm started, and the storm lasted 5 hours. So and it gives you what the derivative of f of t is. So it gives you the original function and the derivative. It says, what was the distance between the road and the edge of the water at the end of the storm? Well, remember that the storm lasted 5 hours. And so your original distance was 35, and you're going to do accumulation 0.5 at f of t. And you're going to do math 9, and you get 26.495 meters. But remember, you had to use the original distance and then how the distance changed. In part B, using correct units, interpret the value of f prime 4 equal 1.07 in terms of distance between the road and the edge. So that's what the after 4 hours, the rate at which the distance and the edge of the water is increasing, because that's positive, by 1.07 meters hour squared, because you're taking the derivative of the rate, so that's how the rate is changing. So the rate at which the distance is increasing. In part C, it says, at what time during the 5 hours of the storm was the distance between the road and the edge of the water decreasing most rapidly? So that's where you want to get your max and mins. So remember, you're going to set your derivative equal to 0 to get your zeros, and you check your endpoints and zeros. And remember, you check it in the original. So you f of 0 will be -2, f of this point will be -1 point, f of this point will be -2.7, and f of 5 will be -0.4803. So it's decreasing most rapidly at this time. So that's the highest amount of the negative numbers. So it's there. So we're going to look at the 2007 in your notebook, Form B. So it's talking about the wind chill. If the air temperature is 32 degrees Fahrenheit, then the wind chill is given by this function, invalid for 5 to 60. Find first derivative of 20 using correct units, explain the meaning. So you're just going to use Math 8, and you're going to get -0.2855 Fahrenheit by miles per hour. And this is the rate of decrease in the wind chill at 20 miles per hour. It says find the average rate of change of W over the interval. Now, anytime it says find the average rate of change, you're using slope formula. And then it says find the value of V at which the instantaneous rate of change is equal to the average rate of change. The instantaneous is your first derivative. Average rate of change is just your slope formula. So average rate of change is going to be W60 minus W5, 60 minus 5. So if you do that, you get -0.254. Now, you want where the first derivative, and so let's use our power rule. So if you do your power rule, the derivative of 55.6 is 0. You multiply this and subtract 1, and you get this. So you're going to set that equal to your average rate of change in your calculator and find your intersection, and it's approximately 23. Now, part C says over the time interval 0 to 4, the air temperature is constant 32. At time equals 0, the wind velocity is 20 miles per hour. If the wind velocity increases at a constant rate of 5 miles per hour, what is the rate of change of wind chill with respect to time at 3 hours? So now this is respect to velocity, and we want to do respect to time. So we need to change our function to have t's instead of v's. So we got to talk about what your v is equal to. So you're going to write your original function, 55.6 minus 22.1. But instead of v, we're going to write what we know. We can replace v with 20 plus 5t. Why can we do that? Because it says it's changing at a constant rate of 5 per hour, and at time equals 0, it's 20. So if I put 0 in there, velocity is 20, and then whatever I put in for t, it will be velocity. So I can replace the v with this. So then I can take my derivative, take the derivative of this, do my power rule. Now remember, when you do your power rule, you have to multiply by the inside. And so you get that. And so if you do that and then plug in 3, you get -0.892 after you plug in the 3 Fahrenheit per hour.